Hello students, welcome to my next online class. So in this video I am going to start a new chapter, that is laws of motion. So in this video we will find that what is motion, what is rest, and what is Newton's law, first law of motion, which is also called law of inertia. What is inertia, types of inertia. So watch the video till the end and don't forget to subscribe my channel to get the latest update, right? So let's start our class today. You see, when an object changes its position with respect to time, we consider that object to be in motion. But if an object's position is not changing with respect to time, that is, it is independent of time here, so we consider that object to be at rest. Okay. It has been seen that whenever any object is on a table, suppose let us consider a marker is on a table, and this marker will be on table until and unless an external force is applied on it. So an object continues to be in a state of rest or motion until and unless an external force is applied on it. So this is called the Newton's first law of motion. So an object will not change its position by itself. Similarly, if you roll a ball on the ground, a ball will keep on rolling until and unless there is a friction between the ball and the ground, or if you are not stopping it. If you don't apply any external force, that object will keep on rolling, right? So this was Newton's first law of motion, which is also called law of inertia. So what is inertia then? It is an inability of a body to change its state of rest or motion by itself. Any body itself, it will not change its state of rest or motion. That means it will continue to be in a state of rest. If it was existing in rest, an object will be in motion if it is in motion, right? So how can we define inertia? What is inertia here? Inertia means here it is an inability of an object which does not change its state of rest or motion by itself, or which resists the change of its state. Now inertia can be of three types, that is inertia of rest, inertia of motion, and inertia of direction, right? Let us consider you are sitting inside a bus and bus was stationary. Suddenly you find and bus is started moving. So when a bus starts moving, as you are sitting on the chair of the bus, you will find that you are jerking in a backward direction. Okay, that means you fall in the backward direction. Why it is so? Because the lower portion which is in contact with the chair of the bus constantly moves in the forward direction as the bus is moving forward, but our upper half of our body will fall in backward direction because it was in a state of rest. Same condition we see, suppose you are in a same vehicle. Now the driver of that vehicle is applying brake. So when the driver applies brake, you find that you lean in the forward direction. Okay, the reason same here. This is due to inertia of motion. When the driver applies brake, the lower portion of our body comes to rest at once, but the upper portion of body which was already in motion, it continues to be in a state of motion, so we lean in the forward direction, right? So this was inertia of rest and inertia of motion. Similarly, inertia of direction, if you have seen a person with those who are sharpening the knife, they are using a stone which is rotating, right? So when you are placing your knife on that rotating stone, so it has been seen that the sparks go tangentially. Okay, so this is due to inertia of direction. So not only this one, we have seen other example also, like during the rainy season when we are holding the umbrella, the raindrops are falling vertically in downward direction. If you are inside the umbrella, you will not get wet until and unless there is a wind around you. So because of wind, the rainwater wets you, right? So inertia can be of inertia of rest. So how can you define inertia of rest? It is an inability of a body to change its state of rest by itself, is called inertia of rest. Inertia of motion, it is an inability of a body to change in state of motion by itself. And inability of a body to change its direction by itself is called inertia of direction. So all these three definitions you can include in one. The inability of a body to change its state of rest, motion, and direction by itself is called inertia, right? The first law of motion defines force as something which changes the state of rest or its motion. Okay, so this is how the force is being defined. Generally, in our junior classes, we have learned that force is that external agency or that term which we use for only for push and pull. But here, the first law of Newton's first law of motion has explained force as something which changes the state of rest or uniform motion of a body along a straight line. Okay, so which changes the state of rest or a uniform motion of any body, that physical quantity is considered to be as force. Next we have what is momentum here. So momentum, it is the quantity of motion possessed by a body. Momentum is measured by the product of mass and velocity. If an object is moving with high velocity, we can say that it has high momentum. In the other way, if the object is heavier, then also we say that the momentum of that particular body is more. That means momentum is directly proportional to mass, momentum is directly proportional to its velocity. So momentum of a heavier body has high momentum, high moving or high velocity of a body also has high momentum, right? So the factors on which momentum depends, that's the linear momentum, depends upon mass and velocity of the object. Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum is directly proportional to external force. If an object is at rest, if I consider this duster to be as rest, it is resting on a table. Now when we are applying a force on this object, an external force, which was at rest, the object which was at rest, it will gain momentum and it will move certain distance. So that means its initial momentum and final momentum will be different, right? So the rate of change of momentum is directly proportional to force. If you apply more force, then there will be more change in momentum. If you apply less force, there will be less change in the momentum. So we are going to derive an expression for the force and acceleration attained by that object. Okay, so let's see here. So F is directly proportional to dp by dt. It is given here. d dt, if I keep as it is, P can be written as mv, right? So mv, now you see, or here we can just substitute dp, means change in momentum. Okay, so change in momentum, so initial moment, final momentum is mv and initial momentum is mu. Okay, so or F is directly proportional to, more precisely if you need to write here, so we can write m into v. Okay, because dp, change in momentum, p means mv, mass will remain same because it is a scalar quantity, universally it will remain same. That means what is getting changed, that is velocity is getting changed, change in velocity. So change in velocity is written as final velocity and initial velocity. So dv can be written as v and u, that means when I multiply here m within the bracket, so let me write it clearly here. So first what I have done here, F is directly proportional to dp by dt. So if I consider as dt same here, P can be written as mass into velocity, right? Because linear momentum, just now I have told that it is measured as a product of mass and velocity, right? Now mass is the constant, mass remains constant, that means what is changing here? Velocity is getting changed and this is dt as it is, right? I have written here as it is. Now change in velocity. Change in velocity can be written as v minus u. This is the change. That is final velocity minus initial velocity. And change in time, that is t minus 0, that is t. F directly proportional to a. Now v minus u by t, that is velocity time relation. We know that v equals to u plus at, or at can be written as v minus u, or a can be written as v minus u by t, right? So what is a here? A is the acceleration, that means change in velocity by time is termed as acceleration. So this acceleration we have here. So in place of v minus u by t, what we can substitute here? Acceleration. So what we got here? V equals to kma, or F equals to ma. Okay, where k is the constant of proportionality, which we take as 1. So one numerical question I have noted on the board, you see. In constant force acting on a body of mass 6 kg, that means mass is given in this question, m equals to 6 kg, right, changes its speed from 4 meter per second to 7 meter per second. That means initial velocity is 4 meter per second, right, and final velocity it has attained 7 meter per second in 50 seconds. That means time is also given here 50 seconds. The direction of motion of the body remains unchanged. What is the magnitude and direction of the force? Okay, so we need to find this quantities. So from Newton's second law of motion we have got this expression F equals to ma, or m a can be written as v minus u by t. Now we will substitute these all values of m, v, u and t. What we will get here in place of m, we will substitute here 6, in place of v we will substitute here 7 minus 4 divided by t, that means time is here 50, right. So what we will get here, 6 into 3 divided by 50, or we will be getting here 80 by 50. So 18 by 50, this is written as 0.36 Newton. Okay. Now we have got the magnitude of that force. Now we need to find the direction. You see in the question it is written that the direction of the motion of the body remains unchanged. That means in which direction the body was moving, the object will be in same direction here. So if I consider that object to be a car, okay, which is moving in a road, its velocity is changing from 4 meter per second to 7 meter per second, right. So velocity is changing, but the direction will be same as that of in the direction which is moving at 4 meter per second. So answer will be, and direction of the force, so direction of the force will be along 4 meter per second. So next question I have noted on the board. You see, on a planet X, a stone dropped from rest falls through a distance of 8 meter in 2 seconds. So the object was at rest, the stone which was dropped, that was at rest, and it falls through a distance of 8 meter in 2 seconds. Time is given 2 seconds and distance is given 8 meter. What we have to find, what is the value of g on the planet? That is acceleration due to gravity, we have to find it. And what is the weight of a 100 kg on the planet? So what is the total weight of 100 kg on that planet? So we need to here calculate here acceleration due to gravity. Okay, so we know s equals to ut plus half gt square, right? When an object is being dropped from a certain height, we use this formula ut plus half gt square, or s you can say the height. Now here in this question you see distance covered, that means s is given here 8 meter, right? U is 0 because the object was at rest, and g dash we need to find here, and time is given here 2 seconds. So if we substitute these values here, what we will get here, 8 equals to 0 plus half into g dash into t square. T we have 2, that means 2 square. If you cross multiply, we will get g dash equals to 2 8 16, right? And 2 square is 4, so 4 will come in denominator, that means 4, that means 4 4 is 16, that is 4 meter per second square. So g we got, so the first answer g value is what, 4 meter per second square. Now what is the weight of 100 kg on the particular planet? And we know weight equals to mass into acceleration due to gravity. So mass is here 100 kg, 100 into 4, that is 400 Newton. So this is our required answer. Okay, so this type of numericals we will be practicing at home. So whichever book you are following, you see the numericals of examples as well as exercise, and write the notes, whatever topics I have taught today, you search from your book and write these notes in your exercise book. So for this video only this much. So see you in my next online class.